Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is solving polynomial inequalities. In this video, we will be solving inequalities that involve polynomials of degree at least 2. Or, to put it in other words, the polynomials won't be linear anymore in this video. So, as we just saw, when solving equations, the process that we have for solving linear inequalities just won't work here. We are going to follow a set of steps that make your job easier in solving any polynomial inequality. Since it is easier to see the process as we work an example. Before that, let me give you the list of steps, 6 steps. Here are the steps. Please have a glance over this. Step 1. Write the polynomial in the correct form. The polynomial must be written in descending order and must be less than, greater than, less than or equal to, or greater than or equal to 0. Step 2 is to find the key or critical values. To find the key or critical values, we always have to set the equation equal to 0 and solve for the variable. Usually we used to get x. Okay. Third step is to make a sign analysis chart. To make a sign analysis chart, we use the key or critical value that we got in the previous step to divide the number line into sections. And step 4 is to perform the sign analysis. Hope you are familiar with this step. We actually divide the entire number line into some sections and then we pick some number in between each of the section and check the answer. Am I right? Yes. To do the sign analysis, pick one number from each of the sections that we created in the previous step, step 3, and plug that number, those numbers you pick, into the polynomial to determine the sign of the resulting answer. The sign of this answer should be either positive or negative, will be the sign of the entire section. You can check different number from the same section if you want to verify your answer. And step 5 is to use the sign analysis chart to determine which section satisfies the inequality. If the inequality is less than 0 or less than or equal to 0, then you want all of the negative sections found in the sign analysis chart. If the inequality is greater than 0 or greater than or equal to 0, then you want all of the positive sections found in the sign analysis chart. Finally, use the interval notation to write the final answer. So these are the important 6 steps we follow in solving any polynomial inequality. So even the quadratic inequalities comes under this because at least degree should be equal to 2. Okay. So let's see examples. Here is an example. X square minus 10 less than 3x. There is a fairly simple process to solving these. If you can remember it, you will always be able to solve these kinds of inequality. First, I'm going to arrange this. I'm going to shift 3x to the left side and I'm going to write this in order. Get a 0 on one side of the inequality. It does not matter which side has the 0. However, we are going to be factoring in the next step. So keep in mind that you are going to do in this step, make sure that you have got something that's going to be easy to factor. So subtracting 3x from both these sides, we will get, hope you're clear with this step. And next step, if possible, factor the polynomial. Please note that it won't always be possible to factor this, but that won't change the things. This step is really here to simplify the process more than anything. Almost all of the problems that we are going to look at will be factorable if the degree is 2. Okay, here if I factor this, I should get negative 10 when multiplied and negative 3 when added. So I'm going to use negative 5 and 2. Am I right? Now next step, determine whether the polynomial is 0. So notice that these points won't make the inequality true in this case because 0 is not less than 0. Am I right? So that is not a problem. These points are going to allow us to find the actual solution. So in this case, the polynomial will be 0 at. If I equate these to 0, I'll get x is equal to 5 and x is equal to negative 2. So yes, negative 5 and positive 2. So what does this mean? That means these two numbers, x is equal to 5 and x is equal to negative 2, are the only places where the polynomial can change the sign. The number line is then divided into 3 regions. In each section, if the inequality is satisfied by one point from that region, then it is satisfied for all the other points in that region. Am I right? If this was not true, I mean, it was positive at one point in the region and negative at another, then it must also be 0 somewhere in that region. But that can't happen as we have already determined all the places where the polynomial can be 0. So this leads us to next step. We are going to graph the points where the polynomial is 0. So hope you remember the test point. I'm going to draw a number line and plot these points and divide the number line into 3 regions or sections. Here you're going to pick some test points and check the sign here. When we pick test points, please make sure that you pick easy numbers to work with. So don't choose large numbers or fractions unless you're forced to do by the problem. So here, starting from negative infinity to negative 2, I'm going to pick one easy number. Let x is equal to negative 3 here. If x is equal to negative 3 here, negative 3, negative 5, and negative 3 plus 2. So that would be negative 8, negative 1, which is greater than 0. It means it is positive here. Same way here, 0 is there, no? So I'm going to pick that easy number. 0 is always an easy number to do with. So 0 minus 5 is negative 5 and plus 2. You'll be getting negative sign here. Am I right? Let me write the number that I pick here. And here I'm going to pick the number next to 5. X is equal to 6. If I plug in 6 here, I'm getting 1 times 8, which is a positive number here. Please note that we plug the test points into the factor form of the polynomial, and all we are really after here is whether or not the polynomial is positive or negative. Therefore, we did not actually bother with the values of the polynomial, just the sign. We can get that from the product shown. The product of the two negatives is positive. Am I right? Okay, same rules of sign is applied here. We are now ready for the final step in this process. Write down the answer. So you have to write your answer in interval notation. If x satisfies this inequality, it should also satisfy the original inequality, no? So that means that all we need to do is to determine the regions in which the polynomial is negative. So for this problem, that is only the middle region, it gives the negative value, no? The inequality and the interval notation for the solution to this inequality are negative 2 to 5. Please notice that we do need to exclude the endpoints. I mean, we don't have the equal to sign here, no? Strict inequality in this case. So we are just not including the endpoints. This is very similar to quadratic inequality. Let me take some polynomial with higher degree. Here is our next example, x cube minus x square less than 9x minus 9. First, write the polynomial in the correct form. The polynomial must be written in descending order as I said. So I'm going to shift all the terms to the left side and I'm going to set one side of the inequality equal to 0. And I'm going to arrange all of them in descending order. So x cube minus x square, if I shift this negative 9x and if I shift this I'll get positive 9. If it is a quadratic polynomial, we can easily factorize that. Okay, let's see how we can solve this one. Find the key or the critical values. So what do? We set the equation equal to 0 and then solve. If I factorize this, I'm getting x minus 1 times x square minus 9. Again, this can be written as a square minus b square format. X square minus 3 square. So a square minus b square is nothing but a plus b times a minus b. I'm going to apply that identity here. If we set each of the factor equal to 0 and solve for x, we will be getting x is equal to 1, x is equal to negative 3, x is equal to positive 3. So we are done with solving part. We have got the critical values. Now let us make a sign analysis chart. To make the sign analysis chart, we are going to use these key values, or you can also say this as critical values. So you can plot these numbers and draw a line on the number line. Now step 4, let's perform the sign analysis. What do? To do the sign analysis, pick one number from each of the sections we have created in this step and then plug that number into the polynomial to determine the sign of the resulting sign. So in this case, I'm going to choose the number next to this, negative 4, and if I plug that value here, I'm getting negative 35. Okay, I'll write it. So whatever value you plug in, you'll be getting a negative value. Same way, in this section, let me pick one number. So here, let me pick there is 0, no? So always I always choose 0 if that number lies in between the region. So when x is equal to 0, it will result in 9, positive 9. So the middle region is positive. And for the third region, I'm going to pick one number. X is equal to 2, that is the middle number, no? That will give me a negative number, negative 5. And for the right side, 3 to infinity, let me pick one number. Let x is equal to 4. If I plug in 4 here, I'm getting 21. We are done with the sign analysis. Now let's use the sign analysis chart to determine which section satisfies the inequality. Here, in this case, what sign do we have? We have less than 0. So, we want all of the negative sections here. So, this one is negative and this region is negative. Open circle, and it is moving towards the infinity. Open circle, open circle. So, this region, let me highlight it. Finally, let's give our answer using interval notation. Okay, negative infinity to 3, union 1, 3. So always follow the 6 steps that I mentioned in the starting of the video if you want to solve any polynomial inequality. If the degree is less than 2, it means it is a linear, no? Okay. So in case if you get any query regarding solving polynomial inequalities, you can let me know. See you in the next video. Have